to class 10. The previous class we have studied about the speed and how to measure the speed and time. Now, this class, let us learn about distance time graphs. See, many a times you might have seen in the magazines or you might have observed when there is a cricket match going on in the TV, they might have shown you the score per over in the form of graphs, So, let us learn what are the various form of the graphs to make it interesting. Okay, so see, I just gave you an example of having score, the score which is being given in the form of a graph during a cricket match. So in such cases, they use this bar graphs to indicate the score taken up by the individual in each over. Say like the x-axis which is present is marked with overs like 1, 2, 3, 4 and 5, and on the y-axis you take up the runs like 1, 2, 3, 4, 5. See, when you look at the runs in the first over, it is only 1 run, and when you talk about the second over, it is 2 runs, and then third over they have taken up 3, and then again when you come to first over, it is in the 1 run. So this is how they indicate the score in the form of graphs, and these graphs are represented in the form of bars. That is the reason this particular graph is said to be a bar graph. And the next type of graph which we are going to learn is a little different as that of bar graph. See, before I start up with the next type of the graph, I just wanted to discuss a little thing which we have learned in previous class, like when we were discussing about the air. And we have spoken about various components which are present in the air, right? What are those various components like nitrogen, other gases and oxygen? So how are these represented? These also can be represented in the form of a graph, but in the form of a pie chart. So this whole of this part which is present, it indicates the presence of nitrogen. And when you talk this part which is present, it indicates the presence of oxygen, and the part which is present here, right? The part which is present here is will indicate the presence of other gases which are present in the atmosphere. This shaded part which is present will indicate the amount of other gases which are present in the atmosphere. So this type of charts which are actually given in the circular form are said to be pie charts. So this really isn't it interesting to learn what are the different types of graphs? Then we'll next proceed with the other type of graph, that is the graph which will help us to know about our age. See, sometimes we keep discussing that, like by the age of 12 or by the age of 3 I was so many kgs of weight, or by the age of 15 I was like put on to 50 kgs or something. So how do you represent this weight according to your age? That also can be represented in the form of a graph, where you can draw this graph. See, when you look at this graph, the x-axis which is taken up as age in years, and on the y-axis we have taken up the weight of the body in the form of the weight of the body in kg, right? In kg. So when you initially look at the age of 2, the boy is of 10 kg, say like. At the age of 4, the boy has increased to 20. Age of age of 8, it is almost 30. So this is how you can represent the age using a graphical presentation, and these dots which are being marked. See, on the x-axis we have taken age, right? So at the age of 2, the boy, on the y-axis we have weight, right? On boy has measured, say like a boy has a weight of 10 kg. So I have to put a dot over here. And then next year. By joining all these dots, you get a line. So what does this indicate? That this indicates the age. This indicates the increase in the weight of a child according to his age. So as these dots are joined in the form of a line, and as this looks like a line which has been joined by various dots, this type of graph is called as line graph. So these are the different types of graphs which we learn or which we see across, like bar graph, pie chart and line graph. Now let us learn how to draw this graph. Now let us learn how to draw the graph. Take a graph sheet. Now draw 2 lines perpendicular. Draw 2 lines which are perpendicular to each other, and mark the horizontal line as XOX. Okay, the horizontal line is marked as X, O and X. The center, okay, the center where 2 lines meet is said to be O. And mark this vertical line. You can see the vertical line. The vertical line is marked as Y, O and Y. Okay, so you see that the vertical line is marked as Y, O and Y, and the horizontal line is marked as X, O and X. So now this horizontal line which is marked as X, O, X is said to be X axis, and the vertical line which is measured as Y, O, Y is said to be Y axis, Y axis. So now you have X axis and you don't have to mark Y axis. You have to draw the lines perpendicular to each other, and the line which is passing horizontally is said to be X axis, and the line which is passing vertically is said to be the Y axis. Now the point of intersection, okay, you see that this is the point where you can see the X and Y axis meeting, right? And that point is marked as O. That point is marked as O, which is said to be the origin. Okay, the point of intersection. See, when I'm just drawing it here to show it again. See, this is Y axis horizontally run, and this is the Y axis which is vertically run, and the X axis which is horizontally run. So you see that this is the point where these two perpendicular lines meet, and this point is marked as O. This point is marked as O, which is said to be the point of intersection or origin. You can also mark it as origin of the graph as O, So now you see that you have drawn two lines, X axis, Y axis, and you have marked the point of origin as O. So the quantities which has to be taken are usually taken in positive quantities on X axis, and the positive quantities on Y axis. So we show the positive values of any graph on horizontally on OX. At the same time, you have positive values on, see, you will have two different values, right, to be taken onto the graph. So one set of the values are taken as OX, and the other set of the values are taken on OY, So similarly, so you'll be learning only about the positive values in this chapter. Now let us assume that your friend has traveled by a car and covered a distance in a particular time. So let us mark a graph indicating like how much distance he has covered within the given period of time. For this, let us make a graph. So now you know how to draw the graph. Take a graph sheet, draw two perpendicular lines. Take a graph sheet, draw two perpendicular lines. Okay, the first thing you have to do is you have to take a graph sheet and draw two perpendicular lines, and first thing you need to do is mark the point of intersection as O and mark the horizontal axis as X axis, which is OX, and you have to mark the vertical line as Y, which is said to be Y axis or OY. So you have taken OX axis and OY axis. Now decide the quantities which has to be taken on the axis. Say like you have to decide which quantity has to be taken on X axis and which quantity has to be taken on Y axis. So as we are talking about the distance and time, let us take the time on Y axis, X axis. Okay, always see that you have to mention the units. Time is taken in minutes, okay, and the distance is taken on Y axis. In kilometers. Okay, so what you have done, you have taken a graph sheet, you have marked the point of intersection origin as O. At the same time, you have marked the X axis as OX, and the next step what you do is mark the Y axis as OY. Then according to the numerical given or according to the plot you have to draw, decide what is to be taken on the X axis and what is to be taken on the Y axis. As we are talking about the distance and time graph, let us first take time in minutes on X axis and distance in kilometers on Y axis. Now you have to choose a scale to represent. So for this, now you have taken the X and Y axis, you have marked them as time and distance, and now you have to choose a scale to represent the distance, and you have to choose another scale to represent the time for the motion of the car. So now let us mark the scale for motion of car. Let us mark scale for motion of car. Say like X axis we have taken. On X axis what is the quantity we have taken? Time. we have taken the quantity as time. So on x-axis the time which is taken, like let us say 1 minute be 1 centimeter on x-axis. So 1 centimeter, you know that there are 10 small divisions in the graph when you take 1 unit of graph. So when you take one single square in the graph sheet, you see that each will have 10 units again. So when you take a graph sheet, this is how one square unit looks like, right? When you're taking the scale as x-axis is equal to 1 minute in 1 centimeter. So this unit, this one small box is said to be 1 centimeter. One small box is said to be 1 centimeter. So you're taking 1 centimeter per 1 minute, 1 centimeter per 1 minute. Then y-axis is equal to 1 kilometer is equal to 1 centimeter again. 1 kilometer is equal to 1 centimeter. You see that the scale is almost every time equal on x-axis and y-axis. So now the scale for the motion of the car, you have given it as x-axis is equal to 1 minute is equal to 1 centimeter and y-axis 1 kilometer is equal to 1 centimeter. Now let us plot the graph using taking the information or collecting the data from the speedometer. Like say very first minute, like 1, 2, 3. Let me mark time in minutes on x-axis first, and then what am I supposed to mark? I'm supposed to mark the distance in kilometers on y-axis. So let me mark the distance as 1, 2, 3, 4, 5. So now we have marked the distance in kilometers and time in 1 minute. So if the car has traveled from, say like this is the origin, the car has traveled from the starting point and in 1 minute it has traveled 1 kilometer. Say like the first minute it has traveled. So when you talk about the zero, see the zero indicates that the car is at rest. That means the car has not covered any distance. So imagine if the car has started from the rest and traveled 1 minute. Within this 1 minute, say like it has covered a distance of 1 kilometer. So represent it like this. And then the next minute it has traveled a distance of 2 kilometers in 2 minutes. And third minute it has traveled a distance of 3 kilometers in 3 minutes. So this is how you represent. So you represent it like 3 minutes it has traveled 3 kilometers and 2 minutes it has traveled 2 kilometers and 1 minute it has traveled 1 kilometer. Now you see that everywhere, you see that according to the plot, you see that the distance traveled in the minute a given time is equal. That means it is covering equal distance in given intervals of time or equal amounts of time. So within 1 minute it is covering 1 kilometer, and the next 1 minute it is covering another 1 kilometer, and the next 1 kilometer it is covering another 1 kilometer. What does this indicate? This indicates the car is moving with a constant speed. So when you try to join the lines right from the beginning or origin, you see that you get a straight line. You get a straight line. You get a straight line where you see this. So from this graph, what do we understand? We see that the distance traveled by the car in the given time is equal. So it has covered a distance of 1 kilometer in 1 minute, and next another kilometer in 1 minute, and the next 3 kilometers. That means it is maintaining a what you call constant speed at a given time. So this straight line indicates that the car or the object which is moving in a straight line is moving with a constant speed, moving with a constant speed. And as we know that, however, the speed changes if the path varies. If the path varies, say like if there are speed breakers, then the speed of the car may vary. And if there are some what you call rumble strips or U-turns, then definitely the speed of the car definitely varies. Unless until there is no obstruction, you can see that the car keeps moving in a straight line with a constant speed. And this is how you plot the distance time graph. This is how you plot the distance time graph. In the same way, you can also use this and mark the distance traveled by you people when you go out for a picnic, okay, in the school bus. You can just take time on x-axis and at the same time the distance covered on your y-axis, and you can see like how long you have traveled. Like in the very first instinct, say like at 8:30 in the morning, if you have started from the school, like 8:30, what is the distance covered? Then you can mark it as you can mark it on the what you call graph sheet. And then 9 o'clock, what is the distance covered? And then 9:30, what is the distance covered? Then 10 o'clock, what is the distance covered? So from this, when you try to intersect, when you try to join the lines which are intersecting through the path of origin, see, these are said to be intersecting lines, right? From the path of origin, you can see there is an intersection of the points on the graph. So when you try to draw the path of origin through the intersection points, you see when it is a straight line graph from the origin, it indicates that your school bus has moved with a constant speed. Okay, the school bus has moved with a constant speed through a straight line, So the convenient way, so this is how you can actually plot a graph using distance and time. In the same way, you can also use the graphs to find out so this is the most convenient way, an appropriate, accurate way to find out the distance traveled in the given time.